All right. So how did everyone make out on PA4? I've talked to most of you individually, actually, so it's a little rhetorical, um, but hopefully PA4 worked out or is working out. Um, and as I mentioned before, PA5 is going to be an extension of PA4. And when we started this assignment, I made some comments along the lines of how sometimes with larger projects, especially ones where there's lots of pieces to organize, sometimes as you work on the project more and more, you eventually come to a point where you say, if I could do this all over again, I would do it differently. I would organize things this way instead of that way, or I would, change the structure of this piece of the code or something. PA5 is kind of a perfect excuse to do that if you've been feeling that. But the deadline was coming up. You may not have had a chance to do that. But now we got 2 weeks till PA5 is due. And this is a good time to sort of, maybe go back and rewrite PA4 using what you've discovered over the past 2 weeks. Probably a lot of your code could be used verbatim, but you might want to change the structure of your classes and how they interact with one another. Or you might want to take something you found yourself doing again and again and again and put it into a method and just call that method. So I'd like to invite you, if it makes sense, to consider, if you feel like PA4, it worked, but it wasn't very clean, it's not something you feel really good about, it's not something you think you completely understand, think about maybe going back and redoing it a little bit. Take a few steps back, because PA5 is really going to be PA4 with a few extra things added in to make it networkable. And the better you feel about PA4, the more you understand it, the less fragile it seems, the more you can concentrate on the new parts for PA5, the networking and so on. What you really don't want to do is, be adding in networking and threads and all these other things, and while you're testing it, find out that you're still having problems with, sometimes when I click, the line doesn't get drawn. Or sometimes, it draws the line for one box but not the other. Or I get a null pointer exception if I'm too close to a dot or something like that. So just something to keep in mind there. So PA4 I will try to get graded in the next few days. It may not be this weekend. Okay, it may not be until, Monday or Tuesday or middle of next week till I get it graded. But you probably have a feeling for how you did on PA4 already. I mean, if it plays the game and it does what it's supposed to do, you get a good grade. If you didn't turn it in, you don't get a good grade. So somewhere in between there. But I will get those graded and I will get feedback posted on Canvas for you as soon as I can. So I did this. Any questions, first of all, before we continue talking about PA4? Anything that you ran into that you want to talk about here? So let me just kind of run through some code that I wrote last year when I first wrote up this assignment, and I was looking at this code a little while ago, and realized that I would write this code differently today, right? Based on what we've talked about and what I've talked to students about and so on. I would do things differently. Okay, so are people having network issues? Okay, I'm gonna kill my camera and save that bandwidth. Oh, the poor camera. And let me take a quick look. and actually just rebooted. Ooh, 100% CPU, that's nice. And that's that, and that's that. Yeah, my CPU is gone. I just rebooted 2 hours ago. All right, if the connection gets consistently bad, let me know, and I'll get rid of some more stuff. So yeah, I started looking at the code I did for this, and I would probably do this differently, but I just want to run through a few things on here just to kind of give you some other ideas maybe of how to approach some of this stuff. So so the box class is pretty uninteresting, right? It's the main object is a box, but it's really just a holder for some booleans for the edges. I chose to use a character to say who owns the box, and I initialize it to a space, and I would make that the initial of, you know, whichever player owns the box, and a reset method that zeroes everything out, which I ended up not using except here. But you know, so that's the box class itself. That's not terribly exciting. And then the main game is dots. And this is mostly, you know, code that was written by Window Builder. So, you know, all of this stuff is boilerplate stuff that was created by Window Builder. The main method is exactly the same as what was created. I didn't touch any of that. My constructor, mostly, you know, setting up the window itself, dropping down text fields and labels and things like that. The main J panel is called main panel, and my main panel is called game, right? So that's the panel on which I'm going to be doing all my drawing. So that gets added, and then these were just, you know, dragged and dropped. Only if Java could I have 10 plus imports. Yeah. And the only other thing that goes on in here, the only thing I really added in here, other than, you know, all the stuff that you get by dragging and dropping in Window Builder, is this one call down here, game.save. Okay, so this is something that we end up doing a lot in this kind of system. So, you know, here's my J-frame, which is called dots. And there's, you know, some buttons and some text fields and whatever. And then there's this panel in here called game, which is a main panel. And that's the thing with the dots. And so remember, the main interaction here, right? You click, and that updates memory. And then the paint method ingests from memory and displays, you know, whatever it should display. So when you click, you don't draw a line. You set a flag in memory which says a line should be drawn here. And then the paint method, you know, looks at all those booleans and draws the lines. And, you know, we'll draw scores and things like that. And so the mouse listener and the paint method belong in this panel, right? Ideally, because this is where you're going to you can store your array, right? Your array of boxes, that's your memory. You can update it in the click listener. You can access it in the paint method, right? But here's the thing. Sometimes the code running inside this object wants access to these things that were declared as part of the J-frame, part of the dots class. And so communication between classes can be a little unobvious, right? Now, since the thing that creates this J-frame also creates the panel, the J-frame automatically has access to everything in the panel, right? It could say, you know, game dot board array bracket such and such, right? So going from here to there is easy because I've got a reference to this, because it's the J-frame code that created the main panel. But inside the main panel code, what if I want to access something from the J-frame, right? I don't have direct access to it normally. So what I do is I have a method in the J panel called save, and I basically pass it these objects. So message, score, player 1, player 2. Those are labels, those are text fields, right? I pass those into a method in the JPanel code, and the JPanel code will basically take these and save them locally. So now inside this object, I've got, you know, J labels that refer to these J labels, and I've got text fields that refer to these text fields, and so on. So that's how you can connect your classes together. One direction you already have, the other direction you can pass references to it. And there's a million different ways to do this, right? I could simply pass this, which would be the dots object, and then inside the main panel object, I could save the reference to the dots object, and then, you know, say that thing dot message, score, player 1, player 2. So there's different ways to do this. But that's one way that I chose to do it. So this was really the only thing that got added by hand in the JFrame code, was just passing a reference to these objects that are created. Let's see. Yeah. Okay. Well, let's take a look at that. So the only other class here is the panel itself, right? So I called it a main panel. It's an extension of a JPanel, and this is where basically all the work happens. Okay, so you know, size of the box 50 by 50, size of the board 8 by 8. A Boolean running flag, which tells me whether the game is running. This tells me if I'm allowed to click and claim lines or not. This is the array of boxes, right? So this is mostly stuff that you know, most people seem to have in their code. Something to indicate whose turn it is. So I'm using an integer player. I'm going to set it equal to 1 or 2 to say whose turn it is, player 1, player 2. Here's the save method for saving that information from the JFrame, and you know, it just takes in a J label called message, and it saves it right here. So in this instance variable. All right, so that's setup stuff. Here's the constructor. So the constructor is basically just going to initialize the board array, and that only has to happen once. If I restart the game, I don't need to reinitialize these boxes. But remember, you declare the board to be an array of boxes, something like this. But those boxes are null to begin with, so you also need to go through and individually set each of those boxes to a new box. All right, so that's what's happening here. And again, most people are doing something like this. And then there's a reset method. So the reset method does a whole bunch of stuff. And the idea was, when you're starting the game, when you give up a game and you want to begin over again, or when you finish a game and you want to start a new game, you have to do a whole bunch of things, right? So all of that, put it in one method, right? So how do you reset the game to its initial state? Well, one thing is set the scores of each player to 0 if you're keeping track of the scores in integers. I wouldn't do this now, but if you're doing that, right? Set the current player's turn to be player 1 if player 1 is going first. If there's no name in player 1's text field, change that text field to say enter a name for player 1, right? And same for player 2. If player 1 and player 2 have the same initial, right, throw out a message, because otherwise you're going to get confused about who owns what box, because I'm using initials in that ownership field of a box. And you know, don't make these editable. Update the score and show whose turn it is, right? So you know, if I'm starting the game over, the score is 0 to 0. But instead of putting something in here which says, you know, set the score label to be 0 and 0, I just call update score, right? As long as I know the score is now 0 to 0, which happens right here, because I set the scores to be 0, I have this method update score which will always display the correct thing on my GUI. So instead of, you know, 15 different places touching that label to change it to say what I wanted to say, I only do that in one place. That's the update score method. And now, if I change that label, if I want to have two labels that show the score of each, if I want to put, a full meter that goes from empty to full as more boxes are claimed and so on, right? All I would have to do is update this one method, update score. And anytime the score changes, I'm going to call this method, and it's going to do whatever I want. So we're modularizing, right? We're thinking of this as something which shows the user visually what the current score is. And if that changes from being numbers to being, bar graphs to being a pie chart to being a color, whatever, it doesn't affect any of the code that calls this method. So thinking of objects. Same thing with show turn, right? I could change the mouse, I could change the color of the board, I could, have a number of different ways to show whose turn it is. It's inside this show turn code. Alright, we're still in the reset function, so I need to clear out all the booleans, so set all the booleans to false, set the ownership flag to be a space, and change the running to be true, to say the game is in progress, and then call repaint, just to make all of these changes actually appear on the screen. So that's the reset method, right, and that's going to get called a few different places. This shows whose turn it is. So right now it's just setting the text in this message box to player such and such, and I'll pick out, the players based on whose turn it is. Alright, so painting is super straightforward and probably looks a lot like your code. So basically go through less than or equal to the board size. So if it's 8 by 8, I need to do a 9 by 9 array of dots. And so just iterate over X and Y and draw an oval. And I did a filled oval, 4 by 4. And then go through, every box in the array. So from 0 to 7 in this case. Calculate the coordinates of upper left, lower right corners. Pick out the box from the array, and then it's just 4 if statements. If the top flag is set, draw a line on top, which will go from, this XY pair to that XY pair. If the bottom line is set, draw from X1, Y2 to X2, Y2, and so on. And then pick out the initial of who owns the box, which is the who field. That's a character concatenated to a string to turn it into a string. Use that with the drawString method and put it near the center of the box. Now you can get into font metrics and see how wide your characters are, and you can actually get the exact width of this character and then take off half of that and half the height if you want it to be perfectly centered. Or, you could just say, I'm going to put this in the upper left corner of the box, or whatever. But, draw the string. So that's the whole paint method, right? And this is called any time that you want to display what the board looks like. And it doesn't do any updating of information, right? It doesn't do any analysis of X, Y versus box or anything like that. It just goes through and it faithfully reads the memory, which is this array, and displays accordingly. And then the other piece is the mouse listener. So when the mouse listener fires, I call this thing called click. I pass it XY coordinates. And it just goes through a series of possibilities. So if the game is not running, display a message saying you got to click the start button and you're done. No need to do anything else. If you come down here, your game is listed as running. So let's convert the XY coordinates into a row and a column. So here's one way to do that, right? This is from that coordinate data sheet, cheat sheet. Just divide by the box dimensions, and that'll give you a row and a column. Make sure it's legal. If the row is too big or small, if the column is too big or small, just return. Don't do anything because they're clicking outside of the board. Otherwise, these are good indices, so now we can access that box from the board array. And then this is a different way to do coordinate arithmetic to find your straight line distance to the 4 edges, left, right, top, bottom. And so in chat you said you understand getting the distances and so on. So once you know the distance to each of the 4 sides, you can do 4 if statements. Right? So if left is less than right and less than top and less than bottom, then they're closest to the left edge. So yeah, or you could do it with a switch, totally. If right is smaller than left, top, and bottom, then they're closest to the right. If top is smallest, they're closest to the top. I didn't want to have the possibility of not having any of these fire, so my last if statement is actually just an unconditional else. Because, for example, if all these distances were the same, none of these if statements would fire. So I made the last one a kind of catch-all. And for each of these conditions, what do you want to do? Well, so we've decided they're closest to the left. Is the left already ticked? If it is, that spot's already taken, return, we don't do anything. Otherwise, set the left flag to be true, and then as long as they're not in the leftmost column, take the column to the left and set its right flag to be true. And so this code just gets replicated 3 more times, and you change left, right, top, bottom accordingly. This is not one to do at 3 a.m. unless you just woke up at 2:30. This is one you got to do really carefully, because mistakes in here are almost impossible to find in code. You can find them by looking at the behavior if you're thinking about it with fresh brain cells. But if you type this carefully, and this is where VI helps, right? You can take this and just kind of modulate it and get these four blocks of code. All right, so that responds to the click in terms of updating memory, and then I call a checkboard method, and checkboard will tell me if any new boxes have been claimed. Well, how do you do that? You go through the whole array of boxes and check to see if all 4 edges are true, but nobody's claimed the box yet. If that's the case, those boxes have just been completed. So checkbox will go through all 64 boxes, look for anything that's new, and it will return a flag saying if a new box appeared or not. All right, call update score so that if new boxes have been claimed, the score gets updated. If no box was filled, let's change players. So if player equals 1, set it to 2, otherwise set it to 1, or you can just do player equals 3 minus player. That changes a 1 to a 2, a 2 to a 1. And then show whose turn it is. And here's the thing. I'm not going to get bogged down writing code saying, let's see if this line that the person clicked is a new box that should be claimed by them. And if it is, I'm going to set a flag so that we don't change the player's turn. And if we go through the whole array and we haven't filled in a box, then we'll change. I'm not going to worry about any of that, right? I'm just going to say, show me whose turn it is, right? And this all up here is just setting Booleans. It's not thinking about turns. It's not thinking about scores. All it's doing is setting Booleans, right? And this is modularizing, within one function, this section of code is doing one thing and one thing only. It's setting Booleans based on the mouse click. And then this line of code, which is, another method down here, is going through seeing if somebody has completed a box. And then this code is displaying the score, and this is deciding whose turn it is. And this is showing whose turn it is, and this is telling me if somebody won the game. Right? So we've seen this kind of thing in main programs, but this can permeate the whole design of our code. Right? This is top down, to a greater degree, where even the lower level methods that we're doing, like, a mouse handler, which is calling this thing as part of the mouse handler, and this is, broken off into a half dozen other functions. Right? But the advantage of this is, I don't have to know where the label is. I don't have to know, whose turn it is and all that kind of stuff. I just say show turn. And, when I'm calling this, I don't know if it's changed players or not. That's decided up here, right? But here, I'm just saying show me whose turn it is. I'm not looking about, did somebody win the game when I'm going through here to see if the last box got filled in and so on. I'm just going to call a method. And that method is going to read from memory and decide if there's a winner. So breaking things into functions. Painting was a bear for me. I had to clear the screen, otherwise it was drawing other pieces outside the board. Sounds like maybe you weren't calling repaint in the beginning. And this one is really, really critical. And if you're finding things not appearing or things appearing in weird ways, it's possible you're not calling the superclasses paint. So double check that. All right, how do we know if someone won? Add up the scores, see if it's equal to the number of boxes. If it is, game's over, so display that message. If the scores are the same, say it's a tie. Otherwise, see which score is bigger and say player 1 wins or player 2 wins. And then change the player names to be editable so that you can change the names before the next game. Or a layout manager issue. And then checking to see if a box is completed, right? So use a flag for a new mark, set it to false. Go through and zero out the scores. Check each box in the board, and if it's completely filled in and it's not owned by anybody, set the mark to true to say that at least one new box is now completed, which will tell us that we shouldn't change whose turn it is, and go ahead and set the who field based on the current player. And then regardless of whether or not this box was owned before or not, right, if it's a new box, I've set the who to be the correct player, and so now if that box is owned, bump up someone's score. So if the who flag matches player 1's initial, bump up score 1, otherwise bump up score 2. And do that across all the boxes, and then just return this flag saying, did we find a new box? So this is modularizing inside modularized code. And there's a lot of different ways to do this, right? I'm not saying do it this way, and like I say, I would do some things differently going back to this, but the more you can sort of break things up like this and localize your tasks, right, probably the better off you are. I would probably not do this, where I bump up the scores like this. I would probably make a method called, get scores, and have get scores just go through the array and count how many boxes are owned by each person. Because having variables like this, now when I want to reset the game, I have to go back and I have to set score 1 and score 2 to 0. Well, I got to remember that, and I got to know that this is updated in multiple places and so on. Instead, what I'd like to do is just have something that returns the score by counting the boxes, and now to reset the game, all I got to do is clear out those booleans and clear out those who flags. And if I do that, and then I say, give me the score for each player, that method would bring back 0, 0. So my overarching takeaway from all of this was I really want this to be a bunch of booleans, right, and a flag for each box. And if I can make that the main thing that I interact with, then I've got a very localized kind of data presence, and that's less stuff to keep track of, less things to potentially break. Let's see. Yeah, so I don't know if that's still a problem or if you fixed that or if you did something else, but I'll take a look at that and see what might have been going on in the paint method. You can certainly clear it by hand, but you should not have to do that. It fixed it. Oh, cool. Okay. Cool. Okay, yeah, I'll be curious to look at that. All right, so let's talk about PA5. And in this morning's class, we had one of my students from the aerospace program come in and talk to the class. So one of the advisors for that program will be coming to this class on Tuesday to talk to us about the aerospace program. So we're going to get through more PA5 in here than we did this morning. So, and then we'll miss something on Tuesday. So let's look at PA5. So PA5 is a networked version of PA4, so it's net dot. And if your PA4 is working well and well understood, this does not take a whole lot to get working. It's surprising how really little extra you have to add on to this. So let me take you through some of the high level aspects of it, and then we'll start digging down into it. And we'll do this a lot more on Monday. But let's start from the top. So first of all, it's another group project, and you have the option of working in the same group, working in a different group, working alone if you were in a group, working in a group if you did PA4 alone. It's totally up to you, right? Just, obviously be considerate of your group members. If you decide you're going to switch groups, make sure you talk to your PA4 members if they're expecting you to work with them and all that kind of stuff, right? Same setup as before. Make sure that your repos are consistent when you submit and that everybody's name is in the top of the Java files and so on. So your basic setup is, well, let me just run this for you. This is worth more than actually. So here's my net.dot program. And here's another net.dot program. And so we have two instances of this game running. Now they're both on my current machine, but these could be on different machines as long as they're accessible through a network connection. Okay, so for me, I've got them both on localhost. When you run this, you're going to have one of these instances of the game acting as a server and the other acting as a client. Okay, so it's going to be a standard client-server model. And you have to kind of decide ahead of time which one is going to be the server, which is going to be the client. So that's, set up through mutual agreement. And so let's suppose that this person over here is going to be the server. So check a radio button that says, I'm the server, and my name is going to be, SSSSS. And this person over here is going to be the client, and their name is going to be CCCCC. All right, so the server has to start first. The server has a start button, which basically starts the server, creates a server socket, listens for connections. So they go ahead and say start. And they can't do anything, right? That shouldn't throw an exception. So, but they can't do anything until a client connects to them. So I might have broken my game by doing that. We'll find out. So the client puts in the machine they want to connect to, which I'm just going to do localhost. The port number 1234 is hardwired. So go ahead and say connect. All right. So both people see the same game. Both of them see a score of 0 to 0, and player one is player one's turn on both of these. You know what? I'm gonna quit this and start again because I think I have a bug and I shouldn't have clicked before starting. So don't have bugs because then your lecture gets like fractured. All right, so we'll make this person the server, and they're going to be SSS, and we'll start the server, and this person will be the client, CCC, and they'll connect. Okay, so they both have no score listed. They both see that it's player one's turn. If player two tries to click, they're going to get a message saying not your turn. Okay, so player one clicks wherever, and it draws a line, and that line appears on both of these boards. And we have a score of 0 to 0. If player one tries to move again, it's going to ignore them because it's player two's turn. So player two clicks over here, it switches to player one goes here, player two goes here, player one goes here, right? So these things move in lockstep. So it's player one's turn. Suppose player one goes right here. They both see that. Suppose player two draws a line right in the middle. They get credit for 2 boxes. They see 2 boxes with a C. The other side sees that. The score changes 0 to 2 on both of these. It's still player two's turn. Player one can't move. Player two can make a move. Player one, player two, player one, and so on. All right, so the game goes on, and it goes on until all the boxes are filled, and then it says who won. And there's a quit button, so you can get out of here. So that's the basic effect of it. All right. So specific requirements. So I want a pair of radio buttons to let you decide whether you're the server or the client, because the startup of the game is fundamentally different depending on your identity. One player is a server, one is the client. Server, you can make player 1, they get to go first. Client is player 2, goes second. Okay, and stick to that so that I have a uniform experience when I'm looking at these. So for starting up, if you're the server, you get a start button. And when you click the start button, it basically creates the server socket, listens for connections on 1234. Takes away the player 2 text field, so you can't set player 2's name, and so on and so forth. For the client, you get a box that says, who do you want to connect to, and you get a connect button. And when you connect, it goes ahead and connects to the server, and you can specify player 2's name, but not player 1's. All right. And then once the game is up and running, it's really easy to keep these things in sync. So you've got 2 boards, you've got lines, you've got boxes, initials, scores, whose turn is it, that kind of stuff. You don't need to share most of that information. You only need to share one piece of information. That's where the click just happened. That's the only thing you've got to share. And so here's the thing. Here's one, here's another, here's a server. Here's a client. Right? If I simply transmit from here to there that a mouse click just occurred at this location, the code you've already written for PA4 will say, oh, there's a mouse click here. It's player 1's turn. Let's go ahead and draw this line. We didn't complete a box. Let's switch to player 2. And now this screen looks exactly like that screen. But really all I did was I said, hey, there was a mouse click right here. And player 2, if there's a mouse click right here, all you got to do is send over to the server the XY coordinates of this click. Hey, somebody clicked right here. And the code that you've already got for PA4 will draw this line, leave the score at 0, 0, change the player to player 1. And this code does exactly the same thing. And so they move together, they update together. And all you're ever sharing is XY locations. So if I click right here, my PA4 code is going to say this box is now owned by C, and it's still C's turn, and the score is 0 to 1. When I send the XY coordinates of that click over to here, if this code treats that as a mouse click, it's going to do exactly the same thing. You can say it's player 2's turn, they clicked here, I'm going to draw a line, there's a box, this is going to be owned by C, it's still player 2's turn, and the score is 0 to 1. So all you got to do is pass back and forth coordinates of mouse clicks. So you get to design your own network protocol, but basically the main thing you're going to do is somehow pass XY coordinates of mouse clicks. You need to do some startup stuff because you need to know each other's names so you can figure out what the initials should be, and you need a way to quit, so you have to pass a quit message. But in general, when somebody clicks, you have your code do whatever it should do in response to that click, but also pass that click to the other piece of the connection, the server or the client. So here's a simple protocol, right? As soon as the connection is established, just send a single line with your name. And then read a single line from the other side, that's the other player's name. And now, anytime that you click, send the XY coordinates of that click. And anytime you receive a pair of XY coordinates from the network connection, treat that as a click. So call your mouse handling code to do all the things that you do when somebody clicks. And that's really all you got to do, because your code is already set up to keep track of whose turn it is, to change turns after clicks. And so if you run your code saying, hey, there was a click at 15,20, and it's the other player's turn, it doesn't matter if the person clicked the mouse or if it came in through a network connection. Your code's already set up to treat that as the appropriate person's line and check for boxes and so on and so forth. And then I just set up so if I send a line beginning with a Q, that's a quit message and it shuts things down. So we still need to talk about sockets, but we've already done server sockets, and sockets are just kind of a subset of that. But that will let us create the client side of a client-server connection. And then we need to start talking about threads next week. Because if we write code that sort of sits in a loop and waits for input to come in from a scanner, if we do that inside, one of our methods in our GUI is going to freeze, and we're not going to respond to button clicks, and things aren't going to get updated, and so on. So we're going to need to create a totally separate thread that's just going to handle the network stuff, and that's going to actually simplify the way we put all this together, because it'll just be a thing off on the side. When we want to send click to the other side, we're just going to call a method, and any time that this thread receives click information from the other side, it'll just go ahead and call our mouse handling code, and bingo, it'll look like somebody clicked the mouse. So we'll start breaking this down more on Monday, but you can go through this and get a basic idea of how to piece it together. And like I said, you can also go back and start patching up PA4 if you feel like you want to change the structure of it. Do you know if the Java GUI part is single-threaded or asynchronous? So Swing runs, my terminology is probably off here, but Swing is basically running in its own thread. And so we have kind of our main thread, which usually exits pretty quickly. We have another thread, which is where Swing is hanging out, waiting for events and so on and so forth. We're going to have a thread that we create explicitly, which will be for handling the network activity. But if you look at the source code for, say, dots, so when you create a JFrame, it creates this thing called a runnable. This is basically creating a new thread, right? So it creates a run method, which basically says in a separate thread, let's go ahead and create this JFrame, and then make it visible. All right, so as usual, lots of ways to structure this. There's some suggestions up there. We'll talk about more suggestions later on. But thinking about this and sort of working out the details before you get too deep into the coding is probably going to be useful. And there's probably a number of ways to do this that will not be very pleasant, but there are ways to do this that make it pretty painless. You can have multiple runnables, you can have multiple threads. That all works really nicely in Java. The only thing is you can't use a thread that's not a runnable to extend a class. So sometimes if you want to extend something and also make it a thread, you turn it into a runnable. But we'll talk about threading by itself next week. And once you get this working, right, you can play your game against other people if you're all using port 1234. If you standardize the protocol you're using, like something like this, then you can, play with other people's GUIs, or, give a friend a copy of your class files, and they can run it on their machine. As long as you have a tunnel to get to the connection, you can play this across the net. Now, most of our routers are sitting behind firewall, acting like firewalls, so we can't get through that, but it's certainly doable. Grading is not very exciting, so downloadable compilable 15, draws a GUI with the required components, another 15 points. GUI updates based on whether you choose to be the client or the server, that's another 10 points, so there's 40 points right there. Establishing the network connection when you say start or connect, that's another 10, so there's half your points. Yeah, dot protocol and specifications, definitely. Handling the names correctly is 10 points. Mouse clicks exchanged successfully and lines are drawn, things are updated and so on, 20 points there. Not allowing out of turn mouse clicks is 10, that's pretty straightforward. And then quitting to shut down, That's another 10. Make your main class net dot, put it in a subdirectory named lowercase net dot. Make sure it compiles outside of Eclipse just by saying Java C and then running it with Java, or give me a make file. What else do I want to say for this first pass through? I think that's all I got for now. The other thing is, you know, as you're playing this, right, so if I make this thing the server, and I say start, oh boy, I got Windows here. So let's make this thing the server and start. I can use Telnet. So I'm coming in on port 1234. I can pretend that, you know, I'm the client GUI, but I'm just going to use Telnet and connect. And I got the name information from the server. It's an N followed by the name. And I'm going to send my name, which is client haha. And now we're connected, we're playing a game. So when the person clicks right here, I get a pair of XY coordinates. And I respond by saying, you know, X 200, Y 75. And that corresponds to a line right here, which would have happened if I had clicked at 275. So you can also test your code using Telnet, right, or some other client program to see what's going on at the low level if you're having trouble with this. Chances are that's not going to be a problem area, though. Really, the trickiest part is just getting things broken out into the right pieces, just like with PA4. The main new piece here being the networked communication, which, like I said, we're going to want to put into a thread. So we'll go through that Friday, or on Monday. Today's Friday. All right, we are out of time, so have a good weekend. I'll get things graded as I can, and I will see you on Monday.